The diagram below shows the path of a model rocket launched from the ground. It reaches a max altitude of 384 when it's above a location 16 feet from the launch site. So they were actually very nice to draw the picture. If you saw those words and you knew the max was 16 feet from the launch site, you should, because of the symmetry of a parabola, be able to establish that it would hit 0 again at the 32 feet mark. Okay? And it asks what quadratic function models the height of the rocket. So I'm going to approach this in vertex form because I see the vertex of the parabola. So remember that vertex form looks like this. And my h and k are my vertex, and I see the vertex happening at 16, 384. So I'm going to use those in my equation as my h and my k. Then I need to determine a. So I either need to know the stretches and compressions, or I can plug in a point from the graph to get a. So the launch spot in this case is 0, 0. So I'm going to actually plug in 0, 0 since it's an x-y coordinate plane pair that exists on this parabola. So I could have done 0, 0 or 32, 0. So this gives me 0 equals, so negative 16 squared is 256a plus 384. And I'm going to subtract 384. I'm going to divide both sides by 256. And then I'm just going to reduce that fraction. So let's see, if I just start by dividing them both by 2, because they're rather large numbers, I'm going to get 192 over 128. I'll just reduce them by 2 again. Again, this is if I have no calculator, no other way of figuring it out. I'm going to do the best that I can. So it's going to be 96 over 64. All right, so both of these are divisible by 8. Oh. And then both of those are divisible by 4. All right, so that's the same thing as negative 3 over 2. Okay, so I'm going to go ahead and plug that in as my a value, and I'm going to have my equation. So y equals negative 3 over 2, x minus 16 squared plus 384.